All right, so with that done, we're gonna set up our ocean, or rather our flip tank and our flip simulation kind of at the same time. The first thing along those lines we'll need to do is set up the colliders. The colliders really is just gonna be one thing. It's gonna be the boat. So make it green, pop in, object merge, should be getting used to this by now. Go grab the boat, it's out null, and bring it into here. There it is. Make sure we hide other objects. Make sure we just have the boat. Could probably turn off the foam thing too. And there you go. In the colliders, we're gonna do a collision source. Collision source doesn't do much. We've seen this in a few lessons now. It's just kind of a convenience tool that on the left input makes it, it does the velocity calculation on the polygonal stuff, and on the right side it just makes a sine distance function, a VDB, kind of like the surface of your water, we'll say vol boat, that we use for volumetric collisions. So there you go, easy. I'm gonna copy polyboat ahead of time because I know I'm about to use it again in our ocean flat tank. Set up. Probably too long of a name, but there you have it. What we'll want here is a ocean source. And let that be mad for a minute. And we'll do an object merge, and we'll do Control V on the polyboat. So there's the boat again into this object. And there he is. That will go into the second input. You can see his collision geometry. That will help the ocean source node. We'll go back to the first frame to see. Oh, the ocean source node is still mad because it's in wave tank mode. Change it to flat tank mode. There we go. And now you can see the boat has carved out some of itself from that. Very good. So we'll put this aside for a minute. We'll come back to it, kind of like a cooking show. We're also going to want to do a actual DOP network for our flip sim. So we'll say sim ocean splash, as opposed to the infinite thing that we've been calling the regular non-simulated ocean. This will just be the splash part of it. So we'll jump in here for a minute. We're just going to do a very basic setup at first, and then we're going to go back to the tank setup. So do flip object, flip solver, gravity, like so. Click them all together. We might as well, while we're here, I always hated this default, which is the guides for the particles are set to sprites, meaning little images. Change that to particles. That's what we want, because we don't want to have like millions of little images of particles when we could just have dots. And while we're thinking of it, do a static object, and this will be for where our colliders come into play. Put the poly into SOP path, go to collisions, and then change this to, or rather change the mode here to okay. Change that to volume sample. If there it is. Volume sample. I feel like Houdini is going to crash any minute now. That's usually what starts to happen. Proxy volume, put that there. And I should say go back up to here and say, where are you? Use deforming geometry. Good. And we'll just merge that in. Now, as by default, it's set to left input, left affects right. So put the static in the left and that in the right. Or you can put it in either order and just change this to mutual. But in any case, so right off the bat, if I were to press play, that liquid should fall, and the boat kind of cuts it. So we can see that it is working. So that's good. Also, while we're here on the flip solver, go to narrowband, enable narrowband. And yeah, so let's definitely not forget to do that. So going back over to the actual tank, let's set it up. Let's set up what it should look like, at least on the first frame. And by setup, I mean, what size should it be? I'm going to say that this can be something that's probably too deep. We need to go up a little bit we want to have enough space for the water to actually fly, like so. And we want to otherwise just kind of capture a radius around the boat. So I'm going to say like 25 by 25. And then we'll move it back a little bit so that it's centered around the boat. So there it is. So that's our first frame. We have a whole bunch of parameters on here that we can hook back into our flip solver, which is why I want to do these both kind of at the same time. Here's our flip object. It takes a particle separation. Well, we actually have somewhere else we can source that from, which is our control panel here. So take our particle separation, which says 2, but should be 0.2, move that to here. So absolute channel references, 0.2. Very good. The rest of them we can come back into the tank here for. So the tank should be getting his from the flip object. So there you go. The grid scale is right here. A lot of these have the same name. If you are ever wondering, like, what should the oversampling be? So the parameter is called oversampling, but I don't know where oversampling is not listed here. You can click on this magnifying glass, type oversampling. Oopsies. And it's not on the flip object, apparently. So the other place it could be is on the flip solver. If we type it here, there it is. There's actually two here. There's oversampling and then oversampling bandwidth. Obviously, it's oversampling is what we want. So reference it here. And I am actually going to change this to 2. Very good. What does oversampling do? Oversampling will put more particles in strategic areas. In this case, it's the surface. And that's usually what we want. The areas that are most likely to be, disturbed, broken, and just otherwise seen are the surface areas. So we put some more particles there. The flip solver, because of the reseeding that it does, allows there to be more particles in certain areas before it kills them. So in fact, here it says death threshold is 1.5. So maybe I will take my cue from that and put this back down to 1.5. If there were more particles than 1.5 times 8, it will kill them anyway. So see the earlier Applied Houdini flip stuff about how reseeding works, but otherwise it's just trying to make sure that it's going to target 8 particles per voxel. If there's less than 4, it will add some, and if there's more than 12, it will remove some. So we are allowed to have more in certain areas, and that will still play nicely with the reseeding. Very good. So we got all those. On the solver itself, we need to do some important stuff in terms of what our general strategy is. In this lesson, we're going to have the bounds of the simulation follow the boat, because as we have here, our camera follows the boat. So parts of it are going to be behind where we started. We can take those liquid areas offline, but we want to have new areas where the boat is just reaching come online. So just so you know ahead of time, we're going to be animating the bounds of this, and as such, animating the bounds of this. In fact, we can just do that now. Copy this to here. So we'll say paste other absolute references, or of course we can just drag it to here, absolute references. So now we can see the flip simulation when we're over here looks like that. I'm going to do hide other objects, turn that off. So the boundaries right now, we haven't actually sourced in anything there, but we can see that the boundary at least is correct now. And as we animate this later on, it will animate the solver boundaries as well. So that'll be nice. So what else do we need to do? We need to take advantage of the fact that the boundaries are changing by saying, hey, fill new volume. As new areas are added to the sim, fill them with particles. Now don't fill the entire volume with particles, fill them below the waterline. That's a pretty key thing here. Our waterline is going to be right here at y equals 0. So as the boundaries change, it will say any new areas add particles below the surface. And because we're using narrowband, it actually won't do all the way to the bottom. It'll just do within those 3 voxel areas. So that's cool. And speaking of the narrowband, we want to take our narrowband 3 voxel thing here, say copy parameter, come back here. The tank has a narrowband thing here, and it has a layer size though. It's not asking for how many voxels. The layer size wants to know in world space units, how many particles should I have? So we know the voxel size in a flip sim is the particle separation times the grid scale. That's the size of 1 voxel. Now there's 3 voxels, so it's this times this times this is this. So let's do that. So copy parameter to here, copy the grid scale, and say that times the grid scale, and then have that be times, and it's going to get mad. Copy that parameter here, come here as well. And now we have our end result. This is really, again, mostly for the first frame when we load the particles in for the first time to kick the solver off. Once the solver is kicked off, it will continue to add particles in the correct manner, as you'll see. So that's pretty easy for the narrowband. The boundary layer is an area towards the edge of our simulation. You can see it represented here as the inner box as opposed to the outer box. The boundary we used in Fluids 2 to add new particles in. In general, for tank kind of simulations, it's basically just a sliver all around the bounds that is constantly being replaced by new particles. And what that does is, if there's a splash, let's say, or like a wave that's moving along the tank, normally the tank walls would be solid, so it'll splash against the solid walls and then kind of start to splash back again. That may not even have a chance to happen in the sim, but we want to make sure that it can't happen. So I'm going to just have it be 0.75, 0.75 on the Z and X axes, and that's going to make a little buffer where, again, it will essentially delete the motion of the wave as it gets there and be replaced by regular particles. At the same time, if there's a depression because of a wave or something, particles will backfill, will flow back into it. So it kind of is just a good way to say this is just a subsection of a larger infinite plane of water. On the solver itself, we need to actually hook that in. Say use boundary layer, and again, bring those over here. We don't need to have a surface volume or velocity volume like we did in Fluids 2. We don't have a custom thing going on outside. The water line is enough to say, hey, in the boundary, just use the water line to constantly keep just adding particles below that. And I don't know, is there anything else on the particles here? Surface, depth is 0, boundary layer, surface value. Yeah, scatter density, that is going to come back over here to our bandwidth business. So we can say surface oversampling goes here. And the oversampling bandwidth we have right here can go here, like so. I'm going to say 2 for that one. I'm going to say 2 for this one too. I'm going back to 2. Just feel good about it. So there you go. That should do a pretty good job. Again, looking at our thing here, we can actually see the particles. We don't actually see them over here yet. We need to actually link them up, and we'll do that in the next chapter.